All right, so here's another combination example. It's this one is solving combination problem by considering cases. So it's been my experience that students have a little bit of trouble sometimes with cases, and this would be an example of a question you'll get where you have to use cases, and I'll explain when I finish reading this. So it says a planning committee is to be formed for a school-wide Earth Day program. There are 13 volunteers, which consist of 8 teachers and 5 students. How many ways can the principal choose? Okay, here's the key. It's going to be a combination problem. Choose a 4-person committee with, or that has, at least 1 teacher. Now, when you see wording like that, at least, or whatever like that, you got to think, okay, I can have 1 teacher and 4 students. Or I can have 2 teachers and 3 students. You see that? So at least means there has to be a minimum of 1. Now, it just has a 4-person committee, so it could all be teachers, I guess. So we have to consider these factors here. Right? Whoops. 1, oh, did I do that wrong? Sorry, it's a 4-person committee. I think I wrote those numbers wrong there. 1 teacher and 3 students, sorry. 2 teachers and 2 students, 3 and 1 and 4 and 0, I guess. So it's got to be 4-person committee with at least 1 teacher. It doesn't say there has to be at least 1 kid or 1 student. So these are the possibilities. So here's going to be case 1 is going to be this one with 1 teacher and 3 students. Here's going to be case 2 and so on, right? Case 3 is this one. Case 4. You guys with me so far? All right, so let's just, actually I'm just going to shift this over so I can control my work here. So case 1, all right, so 1 teacher, so how many teachers? We have 8, and we want to choose 1. That's for that spot. And then for the student spot, we have 5, and I want to choose 3. Does everyone see that? So 8, choose 1, and 5, total students, choose 3. Okay with that? So we're going to find that one. Then we're going to do this second case where we have 8 teachers and we want to choose 2 of them, and 5 kids, students, and choose 2. And so on. 8 choose 3, 5 choose 1, and then 8 choose 4, and 5 choose 0. 5 choose 0. What's 5 choose 0, do you think? What's the value for 5 choose 0? We have 5 and we want to choose none of them. How many different ways can we do that? Is it 1, 5, or 0? Or 1? One way we could choose none? Okay. Why don't you do it on your calculator? What do you get? 5 choose 0. Is it 1? Did you do it on your calculator? Okay. It is 1. You're right. 5 choose 0. Anything choose 0 is just 1. There's one way you could do that. And again, I guess partly the reason why is because of this fundamental counting principle. If you multiplied, if this was 0, like, though there's no way you could choose 0 from something. Well, then this would be 0, and fundamental counting principle problems would collapse because you'd have everything times 0. So this is 1. There's one way you could choose 0 people from a group. Okay, so that's 1. All right. So if we did each of these individually, this one turns out to be 80. I think this one turns out to be 280. So it is this one, 280, and this one is 70. So again, with cases, you want to find out how many options there are for each case, and then it's like or, right? So it's case 1, or case 2, or case 3, or case 4. So when you see or, you add, right? So you have to add all these up. And you should get a number that's like this, 710. So 710, and if it's a word problem, you should end with a word problem. 710 ways a 4-person committee, so on, 4-person committee could be made from 8 teachers and 5 students. All right. Any questions about this example or the solution? You guys pretty confident that you guys can do this stuff now? Combination questions? All right. You have the rest of the class here to work on your assignment, and I'll give you that in a second. All right, so here's your assignment from 4.6. I'm not going to give you an assignment from 4.5 right now. because we kind of rolled these together. So you can see that a bit better. So the one thing you want to remember is the R has to be less than the N, right? So if you have N objects and you choose R of them, the R has to be less than the N. And also, they both have to be greater than 0, no negatives.